Welcome everyone. Welcome to How to Hold a T. My name is CJ Johnson. I work in Google's New York City office on the Abseil team. Abseil is an open source utility library, and you can learn more about it by going to abseil.io. As part of that, I've been participating in the ISO C++ standards meetings, and I also noticed that some people in the audience are here from ORNL. I'm actually from Knoxville, Tennessee, so it's kind of a cool connection. Alrighty, so quick ground rules. Please hold your questions until the end. There are slide numbers at the bottom right of the slides. Just refer to those, write it down, whatever. We'll try to come back to it. And also, just a note that the content of this talk will include half-truths and some incomplete information. This is intentional. It's just to make sure it's more approachable, more consumable. But okay, great. With that, let's get into the content. Let's talk about std vector. And specifically, let's talk about how it contains objects, because it's a container, right? On this slide, we have the function apple. It creates a vector of t and modifies it a little bit and lets it go out of scope. For the purposes of this talk, t just means some arbitrary type. Nothing about this talk is specific to templates. So, all right, let's think about what's going on here. So initially, we're creating a vector. When we create it with default construction, as we're doing here, it does not create any instances of t, and it does not allocate any memory. It's totally empty. But then on the second line, where we're calling reserve with an argument of 1, it will allocate memory for the vector to hold at least 1 t, or exactly 1 t, but it does not call t's constructor. That's important. It's not until the next line, where we're calling pushback, that we're actually constructing a t. But we're not allocating here. It's just calling pushback and constructing a t. And then similarly, we're just destroying a t here. We're not actually deallocating or anything else like that, just destroying it. It's not until the final line, when the vector goes out of scope, the implicit destructor call will deallocate the memory that reserve allocated. So let's think about what this means. We're allocating and deallocating memory here, and we're constructing and destroying a t. But we're doing those things at different times. They're not actually happening simultaneously. So using the same memory, we can actually even do, because of the fact that they're happening separately, we can actually construct and destroy multiple t's in the same memory without actually reallocating. So we're pushing back a t and then popping it back, pushing it back again, and popping back again. These have they're different objects existing in the same memory at different times, but only one allocation. Let's compare this side by side with a different implementation, or a different function called banana, just arbitrary names. Behavior-wise, these are similar. Banana uses stack locals, and it has block scopes to guarantee that it's constructed and destroyed in order, whereas Apple is using a container. Also, Apple uses heap memory, banana uses stack memory, but functionally, they're roughly equivalent. And yet, there's still quite a lot going on here. I'd actually rather simplify this comparison using something called std optional. So optional here, similar to vector, will, as we were doing before, calling reserve a 1, std optional inside its default constructor will allocate memory for 1 t. And then, we're assigning a t into it, which constructs a t, and then calling reset, which destroys a t. Okay, so then you can say std vector, std variant, std optional. These types can be said to hold t's because they manage memory and objects separately. Let's think about how we could implement this behavior, starting by defining some terms. Storage duration and object lifetime. So object lifetime is the time that an object is alive, right? Makes sense. Said another way, it's the time between an object's construction and destruction. Also, storage duration is the time that the memory for t is alive, or a memory for an object is alive, or the time between allocation and deallocation. To really hammer this home, let's diagram these two terms next to actual code. So here we have Apple again, implemented with std optional. To the left of the body, we have 2 vertical bars. The leftmost bar, the one with the solid background, models the storage duration for t, the t that's inside the optional. From the top of the bar to the bottom of the bar, the memory for that t is allocated and valid for use. And then next to that, we have a striped bar. This models the object lifetime of t. It's, from the time it's constructed, destroyed, that's what the bar is trying to represent. Awesome. So if you forget, by the way, if you forget those, just the key at the bottom should make it pretty clear. Cool. So as it happens, in this particular version of Apple, the object lifetime of t mirrors or matches the storage duration. They're happening, the allocation and construction, the allocation and destruction are happening simultaneously. This is normally how it works in C++. If you were to use a stack local variable, you just make a t, it exists for a while, and it destroys. The allocation and deallocation happen with the object lifetime. Also, for heap objects as well, if you use new and delete, they're together like that. You can say that they are coupled, object lifetime and storage duration. They want to happen together by default in C++. But here we have stood optional again. And this time, you'll notice that they're actually decoupled. So at the very top, we are allocating not for one t, but we're not calling the constructor. It's not until the second statement where we actually are constructing a t. And so again, you can see the bar is actually shorter now. And similarly, we could actually call reset before letting it go out of scope, and that will destroy the t before the deallocation takes place. It's on the stack, so it feels weird to talk about allocation and deallocation, but that is actually what's happening here. Okay. In fact, not only can we shrink the object lifetime bar, we can actually conditionally set construct and destroy the t. And in this particular slide, I had to remove the object lifetime graph because there's no way to statically know what the lifetime of t is. It's just fully runtime defined. This is only possible because stood optional knows how to hold a t. So how do you do that? How does one hold a t? So naively, we could think about implementing optional using this kind of layout. Obviously there would be other code involved. This is just the underlying data structure. But yeah, if we have our own optional here with capital O, we could think about doing it this way, where we have a t and a bool. We could model these object lifetime with the hasval by saying, if hasval is false, we ignore whatever val is, we just don't even read it, and it's considered to be empty. So the object lifetime has not begun yet. Or, if hasval is true, we can then say, oh, it has a value, let's read it. As long as we default construct val when we default construct the optional, as we're doing here in Apple, this will actually, in an API sense, give us this behavior where they're decoupled. Unfortunately, this isn't going to get you what you want. So first of all, there's this instance of this optional implementation. I named it slow because, in theory, T could have a very, very slow default constructor. Like maybe it's grabbing some resources, for example. This optional is being default constructed. It's empty. We're not supposed to yet begin the object lifetime of T, and yet we're paying for the default constructor that is very slow. It violates don't pay for what you don't use. But we could say, well, it's an API we want. We really like the ability to have these things separated out, and so maybe we're willing to pay for that. Even then, this still won't work because not all types have default constructors. Stood lockguard is one such example. I'm not telling you to make lockguards, optional lockguards in your code base, but I am using as an example type here to say, theoretically, you could have a type that doesn't have a default constructor, and you want your code to be generic. And this implementation does not work because it fails to compile with such types. So what's the solution here? The reason this implementation fails is that in the language C++, T is the wrong type for holding a T. What? What? T is the wrong type for holding a T. That's right. Instead, you need some other unrelated type that is not T that you use to provide storage for T, and then you manually manage the object lifetime yourself as the programmer. It's crazy, right? Well, let's figure out how to do that then, why don't we? So here we have the set, generally, of storage types you can use in C++ to provide storage for t's. First off, we have align storage here. It's actually an entire category of types. There's align union and pod value holder in Boost that's from eons ago, all kind of stuff like that. But they're generally kind of the same thing. They take in whether it's a type or for align storage's case, a size and alignment, and then they provide you a storage type for t. In addition, we have byte arrays. In this case, I'm using std byte, although you could use char or unsigned char as well as the underlying type. And then finally, we have unions, which I'm sure you've had your fair share of fun with those in the past, right? Okay, so let's start by talking about align storage. Now, up to this point, this talk has just been basically information delivery. Sorry, am I still mic'd? Okay, cool. Sorry. So up to this point, this talk has been basically information delivery. This slide changes that. This slide introduces my opinion. Okay, are you ready? Do not use align storage. Whoa, what? Why would I say this? Well, it's a very strong opinion, but let's talk about why that is. Why do I feel this way? For the long-winded answer to that question, I wrote an ISO C++ standards paper. In it, I advocate for the full deprecation of align storage and align union, P1413. But at a high level, the problems are as follows. First of all, it invokes undefined behavior. I bet you didn't know that. Crazy, right? So the way it's specified, you would think naively that it's actually a type def of a character buffer, but you can't implement that in C++, and I'll explain why in a minute. So it's actually a struct type, which is strict aliasing violation, unfortunately. Also, it's underspecified, so the way it's written, the current language or wording of it, does not have an upper bound on what the size of the type is. So you can ask for a size X and get something much larger than that. And some implementations do that, unfortunately. So it would be an ABI break to fix the wording, so it's unlikely to change. Then beyond those problems, though, that are like kind of nitty-gritty C++ weirdness, the API itself is actually, at least for align storage, rather easy to misuse. So it takes in not a type, but these non-type template parameters for the size and alignment, the second of which has a default value, which is not required to support over-aligned types, so it could be silently incorrect for your type. Kind of weird, especially in the fact that you're required to use reinterpret cast to access the value, which will totally do whatever you tell it to, and will ignore the fact that it's not aligned correctly. Probably not a good way to go. So all right, so that's my opinion. Let's move back out of opinion mode and back into information delivery mode to talk about character buffers. What's old is new again. Yay, C is still a thing. Okay, cool. So for the most part, these will do what you expect them to. There's just a couple gotchas that I think are worth mentioning. So first of all is the interaction between alignment and type def is interesting. So here we have a type def for int that is, I'm asking the compiler to align it to max align t, which is not the default alignment for int. Interestingly enough, this compiles. They're the same type. So int and myint are not actually different types here. Weirdly enough, align as is an attribute, so it's not actually, even though it changes behavior, the compiler is not guaranteed to, it's allowed to ignore it, basically. And so at least in some compilers like GCC, it'll just warn you, like, oh, hey, I'm actually ignoring this thing. I'll compile it for you, but I'm going to ignore it. And then in Clang, it'll, I think, by default fail compile, but you can suppress that. Anyway, there are some configurations where you can accidentally write this code and you think it works, and it doesn't. And this is why you can't implement align storage as a type def of a character buffer, because the alignment cannot be applied here without using another type, such as a struct. Awesome. So then we have the second bullet here. Only a single dimension for the character buffer is allowed. So you have, if you want to make a character buffer like this, it needs to be an array of std byte, unsigned char, or char. Not found in that list is an array of arrays. So if you wanted to make a multi-dimensional array like here, such as shown here. In this case, I want to store in contiguous t's in memory, but this won't actually work. It feels like it should work, but it actually doesn't. So you have to do one of these two things, which is, either compute the size yourself with multiplication, or just what I prefer personally is just size of t array, and then it gives you the right value, and then you pass that into the character buffer. Cool? Cool. All right. Then we have unions. Okay. So first of all, these, at least my opinion is that these are the most compelling way of defining storage types. They're great because they are aligned and sized correctly by default. You just tell it the type you want, and it's like, oh, I know how to make a storage type for that type. And it does it. And in fact, it even works with multi-dimensional arrays. And so each and every, if you were to define it this way using normal syntax, each and every one of the objects in those multi-dimensional arrays has independent object lifetimes that you manage, and you're just guaranteed that the overall type is able to store it properly. Just one gotcha is if you want to support all t's and not just trivial types, you have to manually implement the constructor and destructor for the union, and you have to intentionally leave it empty so that it leaves the value uninitialized. It's a little weird, but yes, that is how you have to define these unions, and then you're free to use the val inside of it as a storage type. Awesome, okay. So the problem with this, though, is that we haven't actually answered the question of the talk. So it's how to hold a t. I've told you about some problems, and I've told you about some types that are confusing, and I don't know, what do they do? But actually, it's pretty simple. So if we want to use them to decouple storage duration and object lifetime, this is what we do. So here we have a union on the stack inside Apple. That first line is where the storage duration for t begins. We're constructing the t val inside the union on there, but we're not initializing it. It's not until the second line using something called placement new that we're actually constructing the t in place. So placement new allows us, as you can see with the address of u.val, it allows us to specify the place in memory into which we construct the t. So it's not actually allocating here like normal new does. It's just constructing it in the existing memory. Similarly, we destroy it using an explicit destructor call, ending the lifetime of t here, but not actually deallocating the memory. Like as before, with an optional, it doesn't deallocate until the very end of the scope. So they're fully decoupled here. This is what you need. And just like on the stack, you can also do it on the heap. Similarly, instead of making it a stack local variable, you make it on the heap. And again, you're constructing using placement new, and it's actually putting the t on the heap in the memory that is owned by UP. Make sense? This is what happens when you actually make a vector or an optional or whatever. This is what's happening under the hood. This is how you do it. We did it. We held a t. Yay! So this talk has been awesome. It took a lot of prep work because it was really hard to convey this information. Like I said, there's some bit of half-truths here. There's a lot of other nitty-gritty details. But the important thing to remember is that you can't actually use t to hold a t. You have to use a non-t to hold a t. Just if you remember that, you can find a lot of Stack Overflow questions going over the exact topic. Alrighty. Thank you. I appreciate you listening. Awesome. Any questions? Yeah?
Yes.
Yes?
Thank you for the talk. Can you please open the slide 24?
Yes, absolutely. I assume I made a mistake?
The third line from the bottom. You said that it doesn't work, but why doesn't it work? Third line from the bottom.
Third line. Oh, yes. So that's a good question. I guess I need to clarify. This line here. So basically, if you could use this for that, yes. What you would need to do, the reason why I say it doesn't work is that you cannot return a .data member that points to the first element here and then iterate to the next element. That would be iterating beyond that'd be iterating to the next thing in memory, but it's not actually technically guaranteed to be contiguous. So you would have to use a fancy iterator that increments to the next thing and then goes back down. You would have to hop basically between the elements, Whereas if you want to return just a range of memory, it would be a strict aliasing violation to do anything other than this, because only these types are able to provide storage for types they aren't. So because this is an array of arrays, not an array, it's an array of arrays of byte, versus only arrays of bytes can actually provide storage for types that aren't themselves.
Okay, thank you. And slide 29, please.
Yes. Yes.
Yes, so on the left, the line second from the bottom, we
Yes.
have to explicitly destroy the type, which, to my mind, violates the RAII principle. So
Correct,
if
yes.
exception happens before destruction, we'll lose.
Yes, that would be, if T holds on to any resources, it would be a leak. Yes, because it's not going to automatically destroy.
Do you have any approach that automates the destruction?
So usually when you're building these generic containers, you have wrapping code around them. So this is going to be inside a container type, right? And so that would be where you would handle the destructor of the container type would then clean up the resources of the T's, as opposed to the T itself.
So that union is expected to be an item of a container?
Yes, it's inside the container, and then the container manages the lifetime.
Okay, thank you.
I can't hear you, I'm sorry. So are we saying exceptions would be, are we saying exceptions could be caught inside the container? So yes, so the container would have its constructor and destructor implemented such that if an exception was thrown through it, the container's destructor would clean up the resources as opposed to the union itself. Yes. So calling a constructor here can throw an exception. Yeah, this is, like I said, this is not complete. This is just slide code. There's a lot more involved in making container types. I just did it to simplify and say this is exactly where T's lifetime begins. This is where T's lifetime ends. And then yes, you would have to make some kind of ability to handle exceptions being thrown. But that would be outside of this particular code. Any other questions? Yes.
Hi, that was a great talk, CJ.
Oh, thank you.
Could you go back to slide 28? Yeah, that's the one.
Yes.
Why do we need a constructor and destructor in the union?
Oh, it's a good question. Yes. So I meant to explain this, and I realized I skipped over that part. So I forget the paper number off the top of my head. Doesn't matter. Back in the day, before there were P numbers, it was actually an N number paper. It was decided that there was motivation to allow non-trivially constructible and destructible copyable T's inside unions. So, for example, in C, everything, there's no constructors and destructors. And so initially with C++, you could only use those types that have trivial constructors and destructors inside unions. But it was decided that that was not powerful enough. They wanted the ability to have non-trivial types inside unions. But it was also decided that because it has this, an actual lifetime, it isn't just raw memory with trivial constructor, there needs to be some, guarantee that it's actually being managed, the lifetime is being managed. And so while it doesn't actually guarantee that, by forcing the compiler to, or by forcing the user to write manual constructor and destructor, you're basically saying as a contract, yes, I know this is dangerous. I know what I'm doing is probably not smart, but I've thought about it a lot. Please let me do this. So otherwise, basically what this means is it doesn't allow it to be defaulted. You have to have something in there that the user wrote. That's the way the current wording is. Now, I actually wrote a paper to change that. It's 1734, I think. But it's still being considered for 23. It's not actually decided yet. So that may change. We may be able to get rid of those at some point. It's annoying because this means that you're incapable of having a trivial constructor and destructor while also having, while also holding a T. But that's kind of a super edge casey thing. So this may continue as is for now. May change at some point. But at least in 20 and prior, you have to write these because the compiler doesn't know how to default them.
Cheers.
Is something follow up on that? Okay, never mind. Yes.
So why are you using placement new instead of just assigning to u.val?
Good question. So I don't know all of the nitty-gritty details, but essentially in C++, because, actually, no, I have a good example of why you can't. So, for example, let's say you have a vector, and you assign into a vector. It needs to, if it owns memory already, it needs to deallocate that first before grabbing the actual memory there. But if it's uninitialized, as we're doing here, it would be deallocating uninitialized memory. So like if t is a vector, on this line, it is uninitialized, right? And so it doesn't actually have a pointer to memory yet. And then when you try to, if you were to assign to it here, it would try to call free on a pointer that isn't valid. It's in uninitialized memory. And so you have to construct it because its lifetime hasn't begun yet. Now, of course, with C types, you can just assign into them. And there's some weird rules around lifetime and stuff, but it works. But with C++ types like this, there's very, very real cases where it does not do what you want and will cause undefined behavior. So if the lifetime has not begun yet, you have to construct it. You cannot assign into it. Now, if there was already an existing vector object in memory there, then you could assign into it, yes. But you have to know that, and that's what you're doing here. You're actively managing that lifetime as a programmer. You can't rely on compiler defaults to do the right thing for you.
Thank you.
All right. I hope you don't mind me trying to restate how you answered
Please
the
do,
previous
yeah,
question.
if it's unclear, please.
So speaking to the comment of this does not behave in RAII fashion, it's not supposed to. So think of this union as of a raw pointer, and you're still going to use raw pointers to implement some kinds of RAII wrappers. But the pointer itself will not give you that. You will have to write the code, and the same is true here with this union. It just provides you a way to represent a thing, but you have to make it well-behaved yourself.
And there are plenty of ways to write exception-safe code that uses this. In fact, that's what I spent my last year on, funny enough. But it was way out of scope for this talk, so I didn't want to include that information. Are we good? Alrighty, thank you. Appreciate it.